one thing, stone cannot be dated.
Cannot be dated, and it's the
no.
only material that will remain for thousands of years.
Stone structures cannot be dated. Secondly, clay can be dated, but stone vases cannot be dated. Gold cannot be dated. So how do you, as an archaeologist, how do you know this culture made this? You cannot know this. Because maybe this artifact was collected by the civilization, and maybe it was created earlier. And archaeologists are so sure about themselves. Why? Well, in my perspective, it would be healthy to doubt the conclusions. But if you ask this question, your whole idea of civilization starts to crumble. And these latest LiDAR discoveries in Mexico, Guatemala, South America, and so on, vast areas are discovered. Tens of thousands of structures hidden beneath the soil and the canopies.
Yeah, it's fantastic.
They are still dated as the Incas, as the Mayas. I say you are crazy.
Welcome to Mind the Shift. Today we're gonna look into our mysterious past once again. The past of our planet as well as the past of our species. And it turns out that they go very closely together. I'm happy to have with me in this virtual studio a returning guest, independent researcher into our antiquity, Mario Buildreps. Welcome back, Mario.
Thank you, Anders. It's great to see you again.
Yes. This is your pen name for those who are not aware of that.
Yeah, it's my pen name.
Let's not complicate things. I know you prefer to use that pen name, so let's do that. Mario Buildreps,
it's no problem for me to explain because I have a career in society and I don't want to mix things up. So,
yeah, it's totally understandable.
So I'm a well-known guy in the Netherlands for all sorts of engineering stuff, and I don't want to be the weird guy because what we are going to talk about is immensely weird.
Yeah, yes, it is.
But it's supported fully by mathematics.
Yeah.
So when I discovered this, I decided to use a pen name.
Yeah. And that's totally fine because, I mean, in this context, the pen name Mario Buildreps is what you're going to be associated with.
Yeah.
I guess once you become famous for this as well.
Or
we'll see.
Buildreps. Buildreps is a typical name. You don't find it anywhere else. So the name started to be somehow a brand on itself. Oh, so it's good. It's good.
Yeah. So your work and your conclusions are astonishing, to say the least, and some researchers, I guess, would say that they are outrageous, of course. And
outrageous, yeah, sure.
As we said last time we spoke as well. But let me try to give the short version here, and you can say if I missed something important here or correct me or so. But let's just have a go at this. Sorry. So the short version is that the Earth has periodically expanded through dramatic deformations of the crust, and this has made the spin axis, the North Pole, move significantly. And where the North Pole has been located can be determined by the orientation of hundreds or even over a thousand, I think, of ancient megalithic structures around the globe. And these anthropogenic remains are, as it turns out, incredibly much older than we are led to believe.
Yeah.
Was that about right?
Yeah, that's the short version. Yeah. And I looked at this research from different angles. So first of all, orientation. Orientation leads to a weird conclusion about our ancient past. And that conclusion is that the North Pole has been shifting over time, the geographic North Pole, because we know that the magnetic North Pole is moving, but we didn't know that the geographic North Pole was moving. That's one. And it's the other angles are ice ages. So when looking at Greenland, there is currently no scientific study that conclusively tells you why there is an ice cap on Greenland.
Yeah, that was something we talked at length last time.
That's important because it's greatly neglected in many researches. It's just accepted as a fact, but you should explain why it is the case. And we think, of course, Greenland is very northerly located, so that's why there is an ice cap. But it's not the only region that is very northerly located. There are regions in Alaska and Russia, and of course Scandinavia as well, where you live, that are on approximately the same latitude as Greenland. On top of that, there is a warm Gulf Stream running along the coast of Greenland, pumping heat from the equator to this massive ice cap. So again, going back to geology, explain me why there is an ice cap in Greenland. And then, because there have been some attempts to do this, and they are outrageous.
Yeah.
Like, for example, there was a big CO2 bubble, or a big bubble with exclusion of CO2 on the location of Greenland, and that's why it cooled down. It's crazy, of course, because
that sounds a bit far out. Yes,
it's far out,
far-fetched.
Far-fetched, and this is done, I believe, by the University of Oxford. Some studies.
Well, it's because they can't. I mean, the obvious thing, or it's not obvious, but the things that you have come up with are when you take them in, they kind of make sense, and they seem more obvious than the other explanations. But they can't leave that basic standard story that they have.
Yeah, and then we go back not to today's situation of Greenland. We go back in time. We go back about 100,000 years, and then looking at how the massive ice caps on the Northern Hemisphere were located. Because that is another topic that needs attention. Because we know the Arctic Circle. The Arctic Circle is centrically located around the North Pole, of course. That's why it is called the Arctic Circle. It's approximately at a latitude of 66.7 degrees or something. Let's round it. Let's round it to 67 degrees. And everywhere you go along this Arctic Circle, there is cold to the northerly of this Arctic Circle, and there is warmth southerly of this Arctic Circle. Can you get my point?
Of course, yes.
Yeah. But what happened with these massive ice caps, they were very, very much shifted. And if you look at how deep this ice cap was located in North America, it went all the way to the Midwest, approximately. But it went hardly anywhere in Russia. And that is weird.
Yes.
That's and another point. Yeah, it's a big thing. Another point is that Greenland was the center point on this massive ice cap.
Yeah.
So we get from different angles one conclusion only, and that is the North Pole has been shifting, and Greenland was the center point of the shift. So
yeah,
Greenland was on the North Pole.
It's compelling when you look at it that way.
Yeah.
And as you say, this eccentricity of the ice cap is actually something that I myself have been pondering before, because it's really strange. Why did it go so far south in North America, and why didn't it go down into Siberia? It's crazy when you think about it. Nobody talks about this in the schools. It's just like it's natural.
But it's coming. It's coming. There's now a geologist in the University of Utah. It's a typical geology university. He's sharing my conclusions about this.
Fascinating.
Yeah.
That's good.
Yeah, that's good.
Good news. Yeah. So I'll just say that I recommend people who are new to these theories to watch the first episode with Mario Buildreps here. I think it was in March of 2023. And I put a link below, of course. I'll also say just briefly before we dive further here that you, to some extent, stand on the shoulders of Charles Hapgood, who already in the 1950s hypothesized that the Earth's crust had been deformed several times. But he wasn't able to calculate it as exactly as you are able to do now, and you and your associates, right?
Associates, indeed, because I have a lot of help. And but we will come to this part later about Hapgood. Hapgood, yes, he put forward some claims about where was this. He didn't talk about deformation. He talked about southerly shift, so the complete shifting of the crust. That is including Antarctica.
Yeah,
and we now know for sure. Pretty sure that the ice cap on Antarctica is over 2.5 million years old, because there's some blue ice found, and inclusions in this blue ice give some estimations of this age of this ice cap. It's old, this ice cap, because for example, if you take these drilling stations on Dome Sea, it's in the perimeter of the South Pole itself. So it's deeply into Antarctica located. There is this ice cap very thick, and they can drill up to 800,000 years back. And this is a consistent buildup of ice. There's like 3 rings of in trees. You can just count, and then count many thousands times of ice layers. So summer, winter, summer, winter, summer, winter, summer, winter, and so on. And this is a consistent pattern, very reliable. And this is not the case on Greenland. This ice sheet is nowhere older than 100,000 years. And what the reason for this is open for debate. Greenland is a pretty small island, so this ice crawls to the outside slowly and then pushes away the most ancient ice cap parts. So there's no evidence that this ice cap is as old as Antarctica.
So how old can it be then on Greenland?
This is, according to my research, it is not older than 250,000 years. It started to grow about 270,000 years on the southern tip of Greenland. So when you look at this picture,
yes, you can explain what you have beside you, that picture, what it shows. Yeah. It shows Greenland in the middle there.
It is an intriguing picture. What it shows is these bands: red, yellow, green, blue, purple. These are called isochrons. And isochrons means time. So what it shows is the expansion of the seabed over time. So red is the youngest and purple is the oldest. And these isochrons show how For example, Africa and South America were pushed away from each other. Because we all know now that they once fitted to each other. They were nested and they were driven apart. This is what they called Pangea. Pangea, all these landmasses were joined together, and then for some magical reason they were drifting apart.
Yes, that's
then,
also something that I've been pondering.
Yeah,
this is a strange theory. If the Earth had the same size all the time, why would all the landmass be in one place and then all of a sudden crack up and start floating away to the other side of the planet without something else happening? It doesn't really make sense.
That's the magic part in science. So there is some magic, some mechanism. No one knows what this mechanism is, because before Pangea there was Gondwana. It was another supercontinent. So looking at it from the sideline, it seems like joining, going apart, joining, going apart. So it's like a sort of breathing. And some people will say, "Oh, this is breathing of the Earth." Yes, sure. No, it doesn't seem so. Doesn't seem so. It seemed to be very unscientific. And
so what happens was that the Earth actually expanded periodically.
Yeah,
and the North Pole was the pole that moved the most. The South Pole was almost in place all the time, but then the North Pole. So if you just again talk about the image you have beside you there, that's the North Atlantic. So you can see that the central parts of the seabed there are the youngest parts, which means that those parts were created by this. It opened up in a way. The Atlantic Ocean,
it opened up. Yeah,
it opened up, and then you can see these red dots on Greenland there, and even south of Greenland. That's the location of the North Pole. Moving
exactly.
gradually.
Let me. Sorry for interrupting you. Thank you for helping me, bringing me back on the path, because this. I will walk the listeners.
We're all good
through a path I have taken. I will do this now, and I started with Hapgood. Hapgood did some research on the shifting crust, and I found it so interesting. And I followed a path of logical thinking. I thought, okay, if Hapgood would be right, there could be some other signs that he is right, that these North Pole positions were indeed on this place, as he suggested. So I went looking for orientation for ancient structures. And in the first place, I thought, just look at it. Because if you go around the world, you find many, many ancient structures, and they are not cardinally aligned. So it means they are just oriented to somewhere. Why? This why question is something for later. I just went looking for many, many different structures, orientation. And if this orientations leads to somehow to certain points that Hapgood suggested as being the North Pole. Because we know if you look at many countries, especially the United States, which is a young country, you look at city grids, railroads, roads, state borders, they are mostly cardinally oriented. So north, south, east, west. It's somehow logic. It's boring, it's logic. And so I just proposed the hypothesis that if ancient cultures were around during these Hapgood poles, they could have been aligning their structures, their ancient structures, to these ancient poles. And that is indeed what I found. I did not find the Hapgood poles, but I found a sort of convergence of the strange location of the big ice cap in ancient times, the reason why Greenland has an ice sheet, and very dense hotspots running over Greenland of orientations. And I'm already about 10 years doing this research. And over these 10 years, I found increasingly more convergence in my research. So I found these typical strange nodes you see beside me. There. You see these?
Yeah.
The red spots are not exclusive orientation points. They are very dense clusters. And it means that between these red dots, there are orientations as well, but they drop significantly. So the density drops significantly between these red dots.
So the vast majority of these ancient structures, they are oriented towards either of those red dots that you are pointing out.
Yeah. It's
not all of them, but
no, 40% are not, and 60% are. And when you do this as a mathematical exercise, you have a certain areas, these red dots, in which you can orient, and you have big spaces in between in which you can orient as well. So I have about 20 degrees of possibility of orientation inside these red dots. And I have about 70 degrees of non-orientation in between these dots. 40% orients in this 70 degree space. So it's very sparsely populated. And about 60% orients in the 20 degrees space. And it's a relatively simple mathematical exercise. What is happening here? Okay, that is one part. And then I went looking for the explanation of why was this happening? Because it's clear that that the pole was wandering, and a wandering pole suggests climate change. And where to look for climate change? That is on the South Pole. So these drill cores on the South Pole. Then I went looking for matching patterns of the movement of the pole and the movement of the temperatures on the drilling cores on Antarctica. And it was an immediate match without much troubles. And that is, so to speak, a match of one out of millions. So my conclusion is that it's relatively simple. Is the North Pole was moving, the South Pole was pretty steady, and this North Pole was moving along this timeline of the ice ages. So this dot here, I call it Pole 5. This one is about 350,000 years old. And then the conclusion is most of the ancient structures oriented to this Pole 5 are probably 350,000 years old.
Mm.
And that is crazy. Okay, just I had to digest this craziness during, I think, about a period of 2 years to understand this is crazy. But then I started to slowly to sink in and started to understand, okay, ancient peoples were just around and building and constructing like we do. But their cultures were destroyed by natural disaster. And then I went looking for, okay, the South Pole is steady and the North Pole is moving. That's weird. What does it mean? There's only one mechanism that can cause this, and that is expansion. And that is what you're looking at in these isochrones. Yeah, this path. These are expansion bands. And there's also expansion bands on the Pacific, and they're much more wild. They're much more red, so much more young.
And that's not disputed. That the fact that the seabed, the seafloor, is much younger than the continents is not in dispute, is it?
No. There's no one that will, with sensitive mind. No, not sensitive mind, but let's say scientific mind, that will dispute this. But where the dispute and the difficulty arises is this Atlantic expansion is relatively simple. Most people understand this. You see these bands. All geologists accept that the Atlantic was expanding in this X direction, in this longitudinal direction that you see. But the difficulty is in the Pacific. You look at the Pacific, it's just one big mess. One red, yellow spot of massive extension. And geologists know that the age of this part of the seafloor, red, yellow, green, is just very, very young. And still, they construct Pangea. Because what happens when you construct Pangea, you shift all these continents together. So you push this Atlantic part inside, and you construct one supercontinent. And what you then do is, on the other side, is stretching the Pacific. And that's strange, because these isochrones suggest expansion. So when you reconstruct Pangea, what you do is not compressing, is you even further expanding the Pacific.
Yeah, because if Pangea was in place when the Earth, a long time ago, and the Earth had exactly the exact same size as it has now, then the seafloor of the Pacific would be the oldest of them all. It would be super old.
It's not this. Geologists just say it's just the case. It's just as it is. It's just as I say it is. It's Pangea and the Pacific somehow contracted, compressed together.
Yeah.
But then explain to me how this mechanism works in relation to these isochrones. And they just get angry, or they just start to talk very difficult things about scientific theories.
Or maybe they talk about the crust being the most volatile part of the Earth, and the inner parts, the mantle and the core, of course, being harder and more difficult to move. So it's kind of floating around on top of this, the mantle, and which would maybe explain that it's much more mutable and movable than people think about it.
Wegener's theory was proposed in the 1920s.
Okay.
So Wegener said Africa and South America were joined together.
Yeah.
And they started to laugh in the geological debate room of all these men with glasses and suits. They started to laugh. And they said, "You're crazy. It's just coincidence." You know, they always say it's coincidence if they don't like it. It's science. It's coincidence. What Mario Buildreps has discovered is just coincidence. This guy is crazy. Of course. Of course I'm crazy. Sure. I have mathematics to back up. So the thing with the Pacific is weird, because somehow you have to construct, if you run, imagine you would be running a movie from 100 million years ago, approximately, until today. So you go from 100 million years back up to today. You run this movie, and what you would see is Pangea joined together. It starts to move. Europe, America, Africa, Argentina starts to move away from each other. And on the other side, Pacific, there's compression. And how to construct this ocean floor with these isochrons with compression is just, I've seen simulations doing this. That looks weird, looks crazy, looks strange. And with this movement of Greenland on the North Pole, I've discovered, you would see that this expansion of the Pacific, which is much more wild than the Atlantic, pushes Greenland over the North Pole. So I started to accept the idea, the notion that these movements of the North Pole on the northern hemisphere, so, was caused by expansion. And here comes the crazy part, even more crazy, because I can calculate the circumference of the Earth using my poles. So I have the position, the South Pole. It moved a bit. I also triangulate this position for ancient structures. And I know the movement of the North Pole over time. So I reconstructed that part.
Yeah. Can I just ask? Yeah.
Yeah. And I can just take you, share screen. Yeah. And here comes the crazy part. So you see here this table. Expansion is the most probable cause. Pole 1, pole 2, this first column, pole 3, and so on. We discovered now up to 12 poles.
Okay, so that's new, isn't it? Because last time we spoke,
I have
talked about 7 poles, I think.
Yeah, 6 poles. So I have now some very powerful research partner on my side who's loading in the whole world. What he's doing is just craziness. And he's really making some leaps forward. So he's helping me fantastically. And so you see radius of the Earth, these table headers, surface area Earth, theoretical G-force, and the age. When you look at the column age, you'll see this 0 to 26,000 years. That is the position of pole 1, the stable position of pole 1. And then you go to pole 2, 130 to 150,000 years, and so on. And
those time frames that you have there, the periods that you enter in that column, those are the time periods when the pole is more or less stable, is it? And
these are, yes.
And the time frames between those periods are periods where it is unstable, and the Earth is probably expanding, has an expansion phase.
Yeah, that's the simple conclusion. And I'm now writing my book, and this will be part of the book, and this part it's consuming a lot of time to base this. Why? Because I had to answer the question not only for myself, also for the readers. Why is it that these time frames of the isochrons of geology is so massively different than my expansion theory? Because there has to be an explanation. And we are struggling, but we are finding real good attachments why and how this works. For example, I'm talking in my book about the great unconformity. I bet not many people have heard of this.
No.
The great unconformity is a really uncomfortable part in geology, because geology is missing some, depending on where you look, between few 100 million years up to 1.5 billion years of layers, geological layers. And like I said, geologists do not like to talk about it, because it's not just a blank spot in geology. It's a massive void in geology, because there are some explanations that say these are ice ages that caused erosion, and then they start talking about snowball Earth, and this melting caused erosion, and then this must have happened and that must have happened. But if you talk about snowball Earth, you talk about the global in its entirety. So erosion goes from one place to another place. There's a net balance in erosion. When you move parts of the soil from this place to another place, you have a gap here and you have a hill there. So you must find somehow a net balance in these erosion patterns. But there's just something missing. And not just something. There are hundreds of millions of years missing. And when you think about expansion, you think, that's interesting. Because what would happen if the Earth expands and the crust is forced to thinnen due to this expansion? This is happening. Parts of the crust are just pulled so much that parts of these layers are missing because they have gone somewhere else.
Gone into the Earth, or?
No. If you imagine...
they moved east or west because of the expansion, and that's why you don't find these layers in some places.
So you will find these layers somewhere else. So there is a big inconsistency in this build-up of layers.
Okay, I get it.
So if you look at all these patterns that suggest one and the same: expansion, expansion, expansion. And this expansion caused the movement of the geographic North Pole, and this movement caused what we call ice ages that we find in the Antarctic ice sheet. So it's one consistent, and it's difficult to explain just in a few words, because it's so vast terrain of observation and mathematical data.
And it's also not immediately obvious why these deformation or expansion periods should create ice ages. Why would it become colder, not as opposed to warmer or something else? I mean, you can understand that there is a lot of things happening on the Earth when it's expanding. There are what we would call giant cataclysms, of course. I mean, the Earth is opening up, and we're going to talk more about the seafloor, I think. But why so much colder? It's not logical immediately to me.
No, because these ice ages are reconstructions based on deuterium isotopes.
Yeah.
And when you reconstruct ice ages as a geologist, you first of all keep the diameter of the Earth the same. You keep the North Pole where it is today. You keep the South Pole where it is today. So you reconstruct what you find in these ice layers. You reconstruct the Earth as a static thing. Of course, there is some Milankovitch cycles. It's just
I know that's the standard explanation. As you say, they point to the Milankovitch cycles as a reason, as an explanation for why we had ice ages. But I don't understand why expansion would create ice ages either.
I understand, because expansion, this expansion is causing uneven expansion. So the Pacific is expanding much more than the Atlantic. And because of this, the northern hemisphere is moving, is tilting very much. So this cold region is tilting and moving. And this causes a strange signal on the Antarctic ice sheet. And when you start drilling in this Antarctic ice sheet and start to determine what is happening, you will find some very strange pattern over there because of this tilting and this shifting and moving as a climatic change. Because this shifting, this deformation, causes not only a physical shift, it also enormously impacts the biosphere. So the biosphere is nowhere the same anymore. So it has to adjust itself as a complicated feedback mechanism. The Earth has airstream and ocean currents and ice sheets and all kinds of winds and systems. And all these systems have to adjust to this new situation. And this takes a lot of time. This takes a few thousand or to a few tenths of thousands of years to adjust, to become calm again. Yes. And this mechanism, you find exact this mechanism in the ice sheet as a pattern.
But I'm thinking those ice ages that we are taught in school happen periodically. There's one ice age 2 million years ago, and then 1 million years ago, 500,000 years ago, and then the last ice age. They cannot have occurred in the same place with your theory. It's impossible. They must have, I mean, the ice caps on the northern parts of the Earth must have existed in different places all the time. Since the North Pole has moved, then this ice cap must also have moved. So it's not possible that we've had these ice ages where the ice sheet has moved further south and then retreated back and then gone down south again and retreated back.
No, exactly.
That's not how it happens.
No, what happens if the pole moves from here in steps to where it now is, you will see that this pole 5 position, that's here, will develop an ice sheet in this region. And it becomes more complicated because I say this movement of the pole was caused by expansion. So you have to compress all these continents more together. And we have been working on a model for this, but we are not there yet.
So, I mean, at some point, maybe a very ancient ice age, if you might call it that, or an ancient position of the North Pole that was very far south, as we see it now. Maybe there was ice in areas that are now Western Africa, for instance, because that continent was much more close to North America, and the North Pole was somewhere around there. I mean, it was not so far from North Africa.
No, there was still, because I've published a movie on this. Now, I think this, I don't know how this movie, this video, YouTube video is called. But I explain how ice sheets develop when the North Pole is moving from position 5 to position 1. So this position 5, there's a North Pole in the ocean. So this cold is transported to the equator.
Yeah.
According to the theory of heat transmission, I'm not saying it correctly, because energy always goes from hot to cold. So I have to say it like this: if the pole 5 is in the ocean, of course it's a cold spot, but heat is easily transferred from the equator to this position.
Mm-hmm.
So there's a difficulty to develop an ice sheet.
So, well, it's a little bit like it is now when we have the North Pole in the northern polar sea, because it's just sea ice. It's not
sea ice. Yeah.
It's not an ice cap per se. It's
not an ice cap, and it's hardly. It has no ground, no power to develop enough.
That's
cold
true. That's true.
To accumulate an ice sheet.
It's only on land that an ice sheet can develop, like on Greenland or Antarctica.
Definitely. Mm-hmm. So if you look at this, how this pole moved over time, it started to come on land on Greenland. And of course, you have to imaginary join these continents a little bit more together. Then there's more power, to more grip, so to speak, to develop an ice sheet. And so that is why I think this ice sheet was coming and going. So it was in pole 5, no ice sheet. It comes on land in Greenland. Then it has sort of the circumstances to develop an ice sheet. It stays on Greenland, pole 3, pole 2. So you're speaking about a long period of time, a few 100,000 years. That is a pole, land masses on the pole. So you can start to develop ice sheets, and then it moves from Greenland back to the ocean again.
Yeah, that's so interesting. It's not like we have ice ages coming and going. It's more like the ice cap or the ice sheet that is surrounding the coldest part of the northern part of the planet is moving. That's what's happening. Nothing else.
Yeah.
That's what we call ice ages. It's not ice ages per se. It's more like expansion periods.
Yeah, it's more or less a relativity point of view.
Yeah, yeah.
So if you start to accept, okay, the Earth is much more dynamic than we tend to think, and we are now thriving as a species. And why is that? Because everything is tranquil and stable. There's no chaos. So civilizations can thrive. And in this period of tranquility and calmness, we tend to think it has always been like this.
Yeah.
It was never otherwise.
That's the gradualism or the uniform.
Yeah, exactly. It's good that you mentioned this, because you have two streams in geology. There is uniformitarianism. It's a strange word. Uniformitarianism.
Everything has been the same all the time.
Yeah,
more or less.
Every change goes slowly. And it never heats up It never cools down. It goes on very slowly. And then you have another stream. And there are just a very, very few people that in geology that attend to this stream. And that is catastrophism. And all the evidence, when you look at it very well, is pointing to catastrophism. So it is too much. And when I step in a very big audience of archaeologists, I would say the ancient foundations of ancient structures point to ancient poles, and they appear to be 350,000 years old. And just quiet for a few minutes. And they start to laugh and laugh and laugh.
Yeah,
and
you have an uphill battle here, but
but I don't mind, because when I would be a professor in archaeology, I would have a problem.
Yes,
sure,
you would.
But
now you're free.
I'm free.
If we go very, very far back into the history of this planet, it's said to be 4.5 billion years old or something like that, right? And so then you can always think, how must it have looked like from the beginning? Because it was created, as they think, from dust clouds that were cast around from after the formation of the sun, and then the whole solar system was created. All the planets were created from these dust clouds, and they were kind of starting to rotate around in spirals, and suddenly they kind of contracted, and they became
maybe
denser.
I do not doubt immediately this
and then
theory.
So my question is, then you can think that, so why would anybody think that the Earth has had exactly the same size all the time? That's a crazy thought in a way. But on the other hand, you might also think that it might have shrunk over the course of cooling down, because it must have started off like as some kind of a gassy kind of planet like Jupiter is today, and then has condensed a little bit. I'm just a layman, but if you kind of think about how it must have been from the beginning, you could either think that it of course it has expanded. It must have been a smaller size from the beginning, or you can think the opposite.
There is a problem with this theory, because you start to pose a few assumptions.
Yeah.
And from these assumptions, you start to build up your foundation and your structure. And there is the mistake. It sounds plausible, I'm grown up as well with this idea of gas, and then starts to accumulate, and then compress, and then becomes hot, and I think it sounds okay to me, but I'm not sure, because it's all an assumption. And from this assumption, you start to build up your theory of the planet.
As opposed to the other way around. We should be the other way around. You look and see what is actually going on, and from there you build up your theory, right?
Yeah. So I do not doubt immediately this. I just, I think, let's calculate back from where we are now today, and let's go back in time. And let's go back in time until I cannot go further. So this is what I've done. And I'm not starting about the formation of the planet, or just, we don't know. And in astronomy, there's so many discoveries lately, last few years, also with this new telescope, how fast planets can be formed. This process appears to be much, much faster. And so there are a lot of discoveries made. And of course, when you find out as an astronomer that planets can form in another way, you can also transport this idea to the Earth and say, okay, what happened here?
So the question whether you believe that the Earth has expanded or shrunk or something has to do also with what you think about the well, I also don't believe that it has shrunk, but anyway, some people might think that. Anyway, also has to do with what you think of where the matter comes from, the material that the Earth is built from. So I know that there are two competing theories here, or maybe more, but one theory that you are not so fond of, I think, is that the matter, the material, the atoms, the molecules that build up the Earth gradually comes from coronal mass ejections from the sun, and we know that there's a lot of material coming out all the time from that end. But then is the question, where does the extra mass go, and how does it enter the Earth, and so but there's another theory that I think you like more. You can correct me if I'm wrong here. It's the decompression theory, that the Earth's atmosphere was much denser, much larger, much higher, much taller, much bigger a long time ago, and then parts of it has gone away, which has meant that the pressure has decreased, which can make the Earth expand for that reason. But I somehow think, I mean, as a layman, you think that the atmosphere, well, that's just air. How can that be so? How can that pressure be so enormous that it can keep a steady, rocky planet together? Can you explain that?
It's good that you mentioned these two theories, and
because it's basic when you think about the expanding Earth. How does it come about?
Yeah, I think it's a more or less a hybrid mechanism. Okay. So I've been thinking about this a lot the last few years, and we've looked into decompression, we've looked in expansion, because decompression says the Earth hasn't changed in mass; it changed in size.
So it's become less dense then.
Less dense, yeah. Exactly. So it was compressed by a very heavy atmosphere, and dinosaurs and large creatures could thrive in this heavy atmosphere because they would have more buoyancy.
Yeah, I listened to Donald Petit the other day because you.
Donald Petit, Donald Petit is a very interesting theory about this, but I think the hybrid is more likely. And we tend to think in left and right and white and black and up and below, and we have to choose all the time, because when you go to elections, you have to choose. When you go to a football match, you have to choose, and you always have to choose. We think in choose, and we have difficulties to think in just joining theories. And it seems more likely because the Earth has a magnetosphere, and this magnetosphere expands into the space about 3 to 4 times the diameter of the Earth. It's large. It's a large net. And this net can catch solar flares of the sun. And every few hundred years, every 1,000 years, a very large X flare hits the Earth. Just boom.
Like the Carrington event in 1859, for instance.
Like the Carrington event. And the magnetosphere catches this energy, these subatomic particles. And because most of the subatomic particles have a certain charge, negative or positive, and because of the ley lines of not ley lines, these flux lines. Sorry, I just talked yesterday to someone who was talking about ley lines.
Yeah, I'm all for ley lines anyway. So
these flux lines, they have a certain direction. So these particles, these subatomic particles, I especially mention subatomic particles, travel in a certain direction. So they will go inside the Earth and create mass. And in the same time, this solar flare blasts away part of the atmosphere. So it's a dual mechanism. It's a hybrid system. So one, there's mass creation, and secondly, because part of the atmosphere is gone, it decompresses a bit. So this mechanism goes both ways. So I think this is how it works. Simple in simple terms. So it's combination of solar flares creating mass inside the Earth, because subatomic particles can go through the crust inside.
Yeah, so in a way you can say that the Earth is continually being created in this solar system still.
Yeah,
it's not done.
It's intermittently created. So by this
yes, it comes in bursts. In
bursts, and when you look over hundreds of thousands of years, it seems like a continuous process, but it goes in small steps because of these solar flares every few hundred years, and then this slow decompression. Every blast, of course, every blast pushes away parts of the atmosphere. Yeah. And so it's interesting. And it's interesting to think about this. And Donald Petit also talks about these flying dinosaurs.
Yes, and I saw that video that he made. It was a talk, I think a TED talk he held, where he explained that these flying dinosaurs, they would not be able to fly if they were here today with this the pressure that we have, the air pressure that we have today in the atmosphere.
Yeah, you can talk about these flying dinosaurs because they're the example and popular in Donald Petit's head. But you can also look at these brontosaurus, these tyrannosaurs, and all these large creatures with these long necks and these tails. And how did they move? How did this mechanism work? Because the blood had to be pumped to the brain, and how does this work in the current gravity? So you have to have, I think, both ways: buoyancy and buoyancy due to decompression and expansion. So when I go back to my screen again, if you don't mind.
No, go ahead.
I look still looking at the same table. This column 4, theoretical G-force. See the theoretical G-force. You see it dropping down from pole 1, 9.81.
That's what we have today.
That's what we have today. Back to 7.74 at pole 6, about 420, 30,000 years ago. And this is not. I want to be clear about this. This is not an assumption. This is more or less between assumption and fact in between.
So it's it's a calculation, but which is built on certain assumptions. It's an exact calculation.
When you look from Donald Petit's mind, he will say it's an assumption. When you look from my perspective, I will say no. I think is pure 100% expansion in this table. But when you fly in parts of decompression, so there is maybe a higher G-force, but more buoyancy. So the result could be the same.
Okay.
So I keep it like this. I choose for expansion, so for mass addition. And maybe in my book, I will make it more hybrid.
I'm so happy that you're writing this book now, because it's really high time, I guess, because this is so much information that has to come to the people. We can talk more about that. So talking about the mass that has been added to the Earth, or maybe not so much because it has become less dense also, but still there is some forms of mass that have been added to the Earth. Another kind of mass that has been that is also a bit of a mystery, which you don't understand is a mystery until you delve into it and start reading about what we all actually are told in schools and all that. It's where the oceans come from, where the water comes from. And there's been this this very dominant theory that I remember I learned many decades ago that, they thought that it has come from space, from asteroids crashing on Earth with ice on them. And in that way, water has arrived on Earth. But then lately, there has been, by lately, I mean the last maybe 20, 30 years or so.
The last decade.
Yeah, the new findings show that water actually exists within this planet to a large amount. And that it's we talked about this a little bit last time. Also, it's a mineral called ringwoodite, which can contain enormous amounts of water. Not in the runny form that we are used to seeing it, but still, it's H2O within that that mineral. And I was reading the other day in National Geographic. There was an article in National Geographic. I think that magazine, for the most part, just conveys the mainstream science as it is today. And it says that most of the mantle is rocky and enormous quantities of hydrogen and oxygen could be trapped inside. Researchers estimate that as much as 10 oceans of water may exist within the mantle. I know you talked about 3, but now they're talking about 10 oceans.
Yeah. There are estimates, and we are sure there are more than one time the oceans over. Yeah, it's locked inside ringwoodite, inside the crust.
Yeah, and this is also just to complete my question or whatever it is here. That means that when the Earth has expanded and the crust has deformed and the oceans or the parts that are now oceans have opened up, then of course a lot of water has probably seeped out into onto the Earth's floor and created these oceans. And that's the explanation because it's a bit of a mystery where the heck did this water come from?
Yeah, we just don't know. And of course, science likes to try to answer these questions. But how is the Earth formed? Where did this water come from? How did it come inside of the crust? I'm more or less not very interested in this story. I'm more interested in human history in relation to the Earth. So there are tales about the Earth flooded completely.
Yeah.
And there are explanations for this. But these stories are the massive ice caps on the hemisphere that were melting, and then so sea levels were rising, and then cities had to move over, and were flooding, and so on. But this is not what the myth is telling. The myth is saying clearly, all over the world, all ancient tribes say the complete Earth was flooded. And this is an oral tradition. And I attach much value to oral traditions. So when I knew, of course, the story of Noah, and this is in the Bible, but this doesn't come from the Bible. It comes from Sumerian tablets. They're ancient. And where does that come from? Does it come from something else? Or is it oral tradition written down? We just don't know. But it's clear that the story tells one day God was angry and he decided to flood the earth because of evil people, giants, Nephilim. You know these stories. Just Bible is a thick book, and just this part is just in Genesis a few pages, and then because it's lost, the story is lost. It's just from bits and pieces of. And when you know that, we know for sure that inside the crust there is massive amounts of water locked in ringwoodite, and ringwoodite can only contain water under pressure in its matrix structure. So when you release the pressure, it starts to bleed water, starts to release water. And when you imagine an expanding Earth, starts to, so let's not talk about compression or expansion solely. Just, I will, for simplicity, mention expansion, so it grows. Then the crust is cracking open. And then along all these thousands of miles, of kilometers of crack line, there's ringwoodite exposed to atmospheric pressure. So it starts to bleed water in massive quantities, like fountains.
Yeah.
And when you imagine the
must be
Earth
spectacular. I wish I could have been there and filmed it.
Yeah, I think it was not so very nice. And when you look through this process from a perspective of a filmmaker, you would make a movie about this. And imagine the Earth was small, just from in the beginning. Let's imagine the Bible. In the beginning, there was a small Earth, and this Earth started to expand, and the crust was cracking open due to this expansion. And water came out along all these cracks and flooding the Earth completely. But the Earth started to continue its expansion process. So the continents were slowly drifting apart, and there were basins forming. And these basins we call oceans today. So the water is slowly retreating from the continents and flowing back into the basins. And then one day, this expansion process came to a halt. The Earth was again in its tranquil mode. Civilization started to thrive. Civilization started to settle along coastlines. There are some oral traditions about a time there was catastrophes. These are just tales along the campfire. We look around and think, there's nothing going on here. And then again, it starts again. And so this expansion continues.
Yeah.
There's another catastrophe.
That's a blockbuster script you have there.
Yeah, it's a blockbuster script. And so these cracks again, because there's still ringwoodite inside the crust in massive quantities. So this cracking starts all over again.
Yeah. So
now it comes from inside the oceans. So again, the sea levels start to rise massively and flooding the continents again. And I think what the Bible refers to, or the Sumerian tablets, or all the myths, is the latest catastrophe. So the movement from pole 2 to pole 1.
You had this table there that you've shown a couple of times, and it shows that the period that has been relatively tranquil now is from, yes, there it is, where we have pole 1, which is the North Pole that we have now, and it's been like that for about 26,000 years. So it's been pretty stable for 26,000 years, as far as I understand.
Yeah.
Which means that many of the other independent researchers that are talking about the lost ancient civilization, they focus quite a bit on the Younger Dryas period, which was, as you know, about 11,700 to 12,900 years ago, which was within this time frame. So that could not have been this pole shift, this expansion phase. So it must have been that cataclysm that you are referring to, the latest cataclysm, must be significantly older than the Younger Dryas that many are talking about. So what's your
Younger
take on
Dryas
that?
I want to talk about Younger Dryas. It's a great suggestion. I have written an article about Younger Dryas where I think it's
something happened, obviously, but maybe not the most.
Yeah, something happened. I can share my screen. I can slowly take you through my thought experiment about the Younger Dryas. Here it is. This is an article on my website. It's for everyone accessible. It is here Earth Science, and then here you see here Younger Dryas impact hypothesis.
Yeah.
Many people do not like it. That has to be said. Wait, if I go to my article. Yeah, here it is. I peeled off what I think happened. And I will take you down to this graph. Because what most people are looking at is this graph, this part of the graph. And they do not look further. You see what I'm pointing to?
Yeah.
It's even said Younger Dryas.
Yeah.
And you see what's happening. Temperature is dropping down drastically.
Well, there's a spike, and then there's
There's a spike and then dropping down.
Dropping down.
But if you continue to look, I made a graph that is called GICC 05 Model X. Not many people know this. And Younger Dryas proponents don't know this at all. And you see these spikes over the course of...
Is this temperature or CO2? What is it?
Temperature. It's a reconstruction.
Temperature. Okay. Reconstruction.
But these temperature proxies are from the Greenland ice sheet. So, and when you know that there is a warm Gulf Stream circulation around Greenland, and looking at this graph, peaks and drop downs, it seems to be intensifying oceanic circulation around Greenland. It then starts to stop again. Stop, intensifying, normalizing. Can you get my point?
So, like the Atlantic Meridional Oscillation, as it's called, the AMO, is whereof the Gulf Stream is a part, I think.
Yeah.
So you mean that kind of circulation and stream can change drastically periodically, and then it comes back, and then
So we agree something happened, and I know this comet impact is popular. It's popular for dinosaurs. It's popular for ancient civilizations. It's just popular because it's simple to understand. You know,
Robert Schoch is more into the theory that it was an unstable sun that was the culprit. Large CMEs.
Could be. Could be.
So there are different theories. It's not just a comet impact theory.
It could be. It could be large activity of the sun. And I don't know the reason why this oceanic circulation intensified and normalized again.
There are also proxies, as you know, they talk about the extinction of the megafauna, for instance, which has happened. Most of it happened during this time, and it's a little bit mysterious. And they have this mainstream theory that hunters were overkilling.
Yeah, I know. This is the mainstream theory.
Yeah, I find it a bit ridiculous, and many don't. But I don't know. It's.
I don't believe, because we believe there were sparsely population, so overkilling doesn't seem to be, and they are not just a few people with primitive weapons. It's very
These
unlikely.
Are big animals,
These are big animals. Yeah, sure.
You would need rifles.
So this Younger Dryas impact hypothesis is popular. It's simple to understand. This pivotal pivot point around 12,000 years. Civilizations before that were advanced. Blah blah blah. Then something happened, and then suddenly it was gone. And when you look at this graph, this GICC05 Model X, I encourage everyone to look into, to delve into this. Just says it's happened many times over the course of 100,000 years.
Why do you think the archaeologists are standard archaeologists, I mean, or any archaeologists are not finding, I mean, I think that, and I think you do too, that the evidence is, as Brian Forrester says, staring us in the face when we look at Sacsayhuaman or Giza or these other structures. These buildings are very, 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 very old. And I mean, if you're in Cusco or in Sacsayhuaman, it's so obvious that the Inca could not have built this, the Inca that we know of, and they even said, for sure. They even said that when the Spaniards asked them. But why do you think it is that? I mean, that's one thing, that the evidence is staring us in the face in a way. But then the standard archaeologists say that no, it was built by the Inca, it was built by the dynastic Egyptians, so on and so forth. But we are looking for stuff in thousands of places, and we never find anything other than remains from hunter-gatherers. That's all we find. We never find any remains from advanced civilizations. Why? We should do that if your theories are right, they say to the independent researchers. So what would be your answer to that standard?
Yeah, it's a great question, because one thing, stone cannot be dated.
Cannot be dated, and it's the only material that will remain for thousands of years.
Stone structures cannot be dated, other than I have discovered. Secondly, clay can be dated, but stone vases cannot be dated. Gold cannot be dated. So how do you, as an archaeologist, correlate this artifact to this culture? How do you know this culture made this? You cannot know this for sure. It's impossible to know this for sure. Because maybe this artifact was collected by the civilization, and maybe it was created earlier. And archaeologists are so sure about themselves. Why? Well, in my perspective, it would be healthy to doubt the conclusions. But if you doubt the conclusions, if you ask yourself, could this be true or could this be false? But if you ask this question, your whole construction starts to crumble, of course. Your whole idea of civilization starts to crumble. And these latest LiDAR discoveries in Mexico, Guatemala, South America, and so on, vast areas are discovered. Tens of thousands of structures hidden beneath the soil and the canopies.
Yeah, it's fantastic.
They are still dated as the Incas, as the Mayas. I say you are crazy.
They couldn't have been doing anything else than building structures all the time.
No, this can never be. This can never be covered in this layers of soil.
Yeah, completely
hidden from view. There's even no oral tradition. Yes, there's some oral tradition about a city of gold somewhere in the jungle. And these cities are now discovered by LiDAR. And these cities are very, very old. And what we find is that all the orientations of these LiDAR cities are all oriented to these ancient poles.
Okay, so you have already started to check the orientation of
consistently
these LiDAR detected or discovered structures. That's cool.
There's no exclusion. It's so self-evident. So when looking for orientations, they're always.
Are they even older than the ones that are? I mean, that we see today, like Uxmal and Chichen Itza?
No. It appears. I've been thinking about this a lot, of course, and what we think is the case, that some structures are reused, renovated.
Yeah.
So if people neglect complete areas, just do not pass it, do not go there, do not remove soil, do not walk, don't use it, it starts to be covered over time. Over a period of thousands of years, it starts to accumulate. But when people visit sites, clean it up, use it, renovate it, it just looks like it is very young.
Yes. You have this fascinating picture on your website of Teotihuacan, which was so covered in soil that it looked like a hill.
Yeah, it looked like
100 years ago.
People believed it was a hill.
Yeah.
It's just that hill there.
Which reminds me of the discussion about this pyramid or whatever it is in Indonesia called Gunung Padang. What's your have you calculated that, the age of that?
Yeah, I know. Let's have a look.
It's not really square shaped. It's a bit diffuse.
No, it's the orientation of Gunung Padang suggests crazy age.
Okay.
And I don't have it prepared now, so
yeah.
Okay, I'm sorry for that.
That's no problem.
But Gunung Padang is oriented to ancient poles as well, to one of the ancient poles.
Okay.
I don't know exactly which one.
Speaking of certain structure, we talked last time about some of them I recall, but I have recently been fascinated by some of the Indian structures in India. I don't know how much you've delved into those, but for instance, the Barabar caves. Do you know about the Barabar caves?
Yeah, Barabar caves, yeah. No.
They are fascinating. I think that they might be the next big thing in the lost civilization crowd, because I mean, the precision of those caves, it's not caves, it's chambers, and they're dug into the bedrock. It's granite. And the precision is similar to what you find in Saqqara in Egypt, in Serapeum, these stone boxes, which is also crazy, precisely made. And I've also seen similar structures in similar exactitude in very, very hard rock, but on a very much smaller scale in a place called Ñaupahuaca in Peru. In a cave, there's a wall there, which is all of a sudden it's just this incredibly smooth granite wall with
very specific sounds,
which is also exactly made, and this it's just incredible. So I mean, those structures must be, and there is not even an oral tradition about what it was from the beginning. So it must be crazy old.
No one knows.
No one knows.
No one knows. We just don't know.
And these Barabar caves, I mean, there are these idiotic theories that, because I mean, some of the kings that lived 2,500 years ago, Ashoka, I think, was one. They had some carvings made into the walls there.
Yeah,
it's just like in Egypt. I mean, of course, kings who discovered these, they claimed them to be theirs, and
this is how it works.
They called them rain shelters. I mean, it's so ridiculous when you look at the exactitude of these structures.
They have very specific sound properties. These caves. So maybe we can just think of some probable uses of them. Maybe for regeneration, rejuvenation, or
the use of sound, perhaps, because they're the reverberation of sound within them.
Sound vibrations. And these are just not normal caves. They are very, very accurately made.
Exactly.
It doesn't make sense.
How much do you think we would find if we looked more thoroughly on the continental shelves? That is, I mean, the seafloor, the shallow parts of the seafloor. There have been, I mean, people have been diving. Graham Hancock has dived, for instance, and many others in. It's called Yonamuni outside of Japan, and then there's the Bimini Road in the Bahamas, and there are.
Yeah.
Do you think we would find much more if we looked very intensely in those areas?
Yeah, definitely, because at a depth of 600 meters, there is an ancient structure discovered by chance, and I'm writing about this in my book a lot.
What is that? Where is that?
Off the coast of Cuba, there is a structure discovered by accident by oil guys scanning the seabed, looking for oil, and they stumble upon a structure. And the structure is it's just, the archaeologists say this cannot be true, but it is true. It is scanned.
Looks like a pyramid or something, or
yeah, there's city. There's Mayan-like structures.
Okay, is that the one that is?
I can explain this.
Is it to the west of Cuba or to the east?
It's to the northwest of Cuba.
Okay, then I think I've heard about that, because it's in the Gulf of Mexico. Yeah, I've heard about that, but it's
And so when parts of the seabed is stretched and thinned, so it sinks down.
Yeah.
Flooded. So it's for me, it's a simple explanation. I understand this. Of course, a few years ago, about 5 years ago, I didn't understand this Cuban structure, but then I started to delve deeper, understand this whole mechanism, this whole system, because I couldn't believe it was true. Expansion so young, but then it appears this is the explanation why the structure is at this specific depth. And then just recently, there was along the coast of Brazil, a sunken island discovered. A huge island, just sunken into the depth, at the same depth of approximately 600 to 700 meters. So it's probably, when you would be diving over there, you would probably find some structures.
So just to give an idea for those who are new to this, how old are these, in your calculations, the oldest structures that you have measured? Considering their orientation towards different poles that have traveled over Greenland. So how old are the oldest, and which ones are those? If you give some examples of that.
Oh, I have such a long list. I cannot always.
I know you've calculated over 1,000 objects, isn't it? Or
over almost 1,200. Yeah, now.
So give a number of these oldest megalithic structures that you have found.
We're not sure about this.
300,000?
No.
Older?
Yeah, they go up to 800,000 years.
Oh wow!
Yeah, and this is the crazy part of the story, and this is hard to believe. But the data is clear on this. The data is so specific, so clear, so it's shouting out loud. The message is: we are here for more than 800,000 years, building, thriving, catastrophes, diminishing in population, then growing up again, climbing up again, diminishing, climbing up again. And so this is how it works. And this is the crazy story. We, as Homo sapiens, are the young species. We came, we don't know exactly when.
And how it happened. It's also
how it happened. Yeah. This is the speculative part of the story, of course. I sometimes go into there. How did we get so many genetic mutations?
Is the chromosome number 2, for instance, is very mysterious, and
there's so many mysteries, and I leave this to other people. Let me just do the thing I'm good at, and that is
yes, your table is full anyway, so you have
data collection, and just do the math, the signals, and so on, the interpretations, and then come up with numbers. This is my strength, and now I have even more power added to it in the form of my research partner, who is doing this work full time. So
fantastic. You have. I know you cooperated with some, I think, geologists or so before, and then they quit. But you have some other associates now that you're working with.
Yeah, I have more consistent associates, and because when I work with geologists and start to talk about expansion is young, they just quit. They just you're crazy, crazy
But you
guy.
mentioned this researcher in Utah who is now into your hypothesis. That was interesting.
Yeah. But we disagree on many things. We agree on the pretty catastrophic migration of the North Pole.
Okay,
We
well,
definitely agree.
That's critical.
Yes, but we disagree on very very much other things.
Okay,
so,
but that's okay. I mean, it's science.
It's okay. And I say no. Antarctica is stable. We know this. He says no. Antarctica moves as well. I say no, because we know Antarctica didn't move. You can see this in data. It didn't move.
But this is a researcher scientist who has tenure at the university, is it? Who is it?
Yeah.
You say his name?
I'm not sure if he likes it.
Okay. Yeah, but I mean, it's interesting that it starts. I mean, it has to start somewhere. If you have a mainstream scientist with tenure at a university who are on board with this hypothesis, at least in parts, then you have something has happened. So
yeah, of course, something has happened, and I don't know exactly how it happened, or maybe did some part in this. But he is all into Greenland and the ancient massive ice sheet.
Oh, that's cool.
That cannot be explained other than Greenland was on the North Pole.
Yeah, I think it's a good thing if you can get more and more scientists and researchers to just step back a little bit and acknowledge the gaps in the theories, the gaps in the hypotheses that are mainstream. Because that in and of itself should make you ponder, should make you think a little bit, and just to recognize that we don't know this, and this is in and of itself, I mean, reason enough to be a little bit more open to alternative ideas.
Yeah, openness is, of course, a typical problem in science because it's very conservative.
Yeah.
And, it costs so much energy to have discussions with scientists about yes and no and this and that. I have no time for this. I need all my energy and my time for writing my book, doing my research.
And it's wonderful that you are independent and you have the means to do it also because you were a successful businessman and you can do this, and that's great. I just appreciate that. And speaking about your book, we have to mention that as well. I'm happy that you're writing it. And how far has it come? And what audience are you targeting here? Does it cover the whole spectrum, or are you?
Yeah, it covers the whole spectrum.
Okay.
Yes. And it doesn't. The book is mentioned to be for laymen, so everyone must be able to read it. It must be accessible.
Excellent.
So that's simple explanation. All the mysteries we find out there. And what's the explanation for this?
So when is your book coming out? Do you know?
Yeah. More people. I said to some friends, it will be 2024, but it's not because my research partner is also discovering new things, and I have to go back and then rewrite some parts, and then I just make progress chapter by chapter, and then I discover new things.
Yeah, but you know what you do is you just decide to stop the research at one point.
No.
Publish, and then you write a part 2.
No, it's too complicated because of course I can make a reprint, but no.
Otherwise, you will never come to a finish point.
Yeah, yes.
You think
because
so?
the book is about 80%. I've come a long way in this book.
Okay, well,
but the book must deal with the difficult parts, the really difficult parts, and that is the explanation for the expansion, how this mechanism works, what is going wrong in the dating techniques. So this is the really, really difficult, hard part I'm now chewing on. Because like I say, I neglect this, but I don't want this.
I look forward to it, and maybe I can review it somewhere. I don't know. I sometimes write stuff for newspapers here in Sweden.
Nice.
Yeah, so that I would appreciate
to be nice.
anybody if somebody wants a review on it, but I would be happy to do that. So hopefully it will to come out later this year, or maybe in 25.
No, it won't be this year.
It won't be this year. Okay.
No.
So then that means that
it will be in Dutch initially, and it has to be translated again.
Yeah. So. Okay, so that means that you will have to come back to Mind the Shift once again.
Sure, no problem. It's very nice to talk to you. When your
book is out, you will come back, right?
Yeah, sure, I will.
Okay, so thank you so much, Mario Buildreps, for the show once again, and good luck with your research and your book and all that.
Okay. Thank you.
If you like this video, don't forget to subscribe, and don't forget to hit that like button and share the video with your friends. Please support the channel if you can. I appreciate all the support. You can become a Patreon for as little as $1 a month, or you can make a one-off donation via PayPal if you wish. All the links are in the description box below. Thank you.